Calculate and interpret the sources of return from investing in a fixed rate bond. So we do have a calculate keyword here. There are three sources of return if you're holding a fixed rate bond. Number one, the receipt of promised coupon and principal payments on scheduled dates. Wrapped up in there is your yield to maturity, because you're going to get the coupons on a specific date and that bond is going to amortize towards par at a certain rate. So you will get, over that period of time, the yield to maturity at which you originally bought that bond. Number two, the reinvestment of coupon payments. And when we have that, we introduce interest rate risk. If rates rise, we can reinvest those coupons at a higher rate. If rates drop, we can reinvest at a lower rate. Number three, and this one's not so straightforward, the potential capital gain or loss on the sale of a bond prior to maturity. Let me explain why that's not so straightforward. Let's say that this is par and this is maturity at time T, and we buy a bond at 80. We know that over time, all the way to maturity, that bond will amortize its way to par. That's the amortization of the discount. Let's say we sell in 5 years for 90. And 90 is on this amortization curve. In other words, that's the amortized value of the bond. You may say, well, there's our source of return, 80 to 90. There's number three. We bought it at 80. Wrapped up in the original price that we bought it was our yield to maturity. And we knew the discount would amortize to par over time, and we sold the bond on that amortization curve. We sold it for its carrying value. That's wrapped up in yield to maturity. That is not a capital gain or loss. For there to be a capital gain or loss, we must sell it above its amortized value or below its amortized value. And a bond's price would end up there if interest rates change. So there is the second impact of interest rate risk is on the price of the bond. A buy and hold investor has no return from source three. A buy and hold investor's source of returns are 1 and 2. If you're going to sell the bond before it matures, in other words, your investment horizon is shorter than the maturity of the bond, then you have price risk in both the reinvestment of coupons and in the price of the bond when you sell it at whatever the end of your investment horizon is. So let's look at a bond and two different investors, a buy and hold investor and someone with a 4-year horizon. We're looking at a 10-year bond, 6.2% annual bond, selling at par. And we're going to assume no change in rates over that period of time. Coupons can be reinvested at the yield to maturity rate, which in this case is 6.2%. So let's look at the future value of the coupons, 82.49256. We're going to get 6.2 per year. We're going to reinvest it in 10 years. What will be the future value of that stream of cash flows? We did this in quant, right? N is 10, payment is 6.2, present value is 0. There's your interest rate factor. Compute future value, you'll get 82.49256. But we know that 62 was from coupons because we got 6.2 per year times 10. 62 was from coupons. The 20.49526 was interest on interest, or was source number 2 of our return. The reinvestment of coupon payments. That is the return on our reinvestment. The 62 was part of return source number 1, the receipt of promised coupon and principal payments on scheduled dates. So our total future value will be 182.4926 because there is the 100 we get back. We bought it at 100, we'll get 100 back. Future value of coupons was 82, 182. Our horizon yield is 6.2%. If we have a 4-year investment horizon, the future value of our coupons is 27.203. N is 4, payment 6.2, PV 0, your interest rate factor 6.2, compute future value. However, 2480 was the receipt of the 4 coupons, so the interest on interest component was 2.4032. There's source number 2, there's source number 1, and we're going to assume that we sell it for the same 100 that we bought it. In other words, no capital gain, no capital loss. We sell it for 100. Our horizon yield is 6.2. Where this begins to change for the buy and hold investor is on number 2. We have interest rate risk on our reinvestment. Where it begins to change for the buy and sell holder is reinvestment of coupon and the potential capital gain or loss by selling it off of its amortized value. So more formally, this is what I was referring to on the previous screen. We can buy a bond at par, we can buy a bond at a discount or at a premium. If we buy at discount or premium, on maturity, that bond will be par. And here is maturity at time t. The discount will amortize, the premium will amortize, and every point along this curve is the bond's carrying value, which is the original price we paid plus or minus the amortization of any discount or premium. It will be plus the amortization of the discount, and it will be minus the amortization of the premium. This line here is a price trajectory, but a very specific type of price trajectory. It is a constant yield price trajectory. In other words, we're saying if the yield stayed constant, what would be the expected price trajectory? And this is simply nothing more than the amortization schedule of any discount or premium. If we sell a bond anywhere on this curve, we do not, for the sources of return, we do not experience a capital gain or a capital loss. Your taxing authority may have a different opinion, however. They may say that any difference between what you paid and what you sold it for is in fact a capital gain, when in fact it was nothing more than part of the yield to maturity that when you bought it. But for sources of return, just for sources of return, if you sell on that price trajectory, you do not have a capital gain or loss. It is just part of your yield to maturity. Okay, let's go ahead and change interest rates. We have a buy and hold investor. We have the 4-year investment horizon. We're going to use the same bond that we had on the previous screen. We're going to increase rates by 100 basis points before the first coupon. Remember, the buy and hold investor doesn't have any source of return from capital gain or loss, just from the original yield to maturity and the reinvestment of coupon. So I look at that, I say, well, rates went up. You can reinvest the coupon at a higher rate, period. You're going to have a higher yield, realized yield, than the yield to maturity. So future value of the coupon is 86.4754. Our payment is 6.2. Notice our interest rate factor is 7.2. Total PV, we add our principal on, 186.4754. Our horizon yield is our future value over our present value, and we take the t root of it, 1 over t minus 1. We get to 6.4295 versus 6.2. Could have told you that. Could have told you it would have been higher than 6.2 because we have no price risk. We only have reinvestment of coupon risk. For the 4-year investment horizon, we have two sources of risk. We have the reinvestment of coupon, which we know will be beneficial, and we have price risk, which we know will be detrimental. Yields up, price down. The question is, does the extra return from the reinvestment of coupon offset the loss that we will receive by selling the bond at a lower price? So interest rates change. If we go back up to the little chart I drew at the top here, we had a par bond, interest rates change, the price immediately dropped, we now have a discount bond. 4 years later, and I'll just do a little tick down here, 4 years later we sell the bond. Did the bond, from a discount bond, have enough time to amortize over that 4 years such that the loss on the price of the bond is offset by the gain on the reinvestment of the coupon? If it was, then we realize our yield to maturity without having to hold it for 10 years. Let's find out. Future value of our coupons, 27.6092. Our N is 4 in this case. 6.2 is our payment. 7.2 is our interest rate factor. Present value of the bond, 95.2627. We have a 6-year bond that's left, future value of 100, payment of 6.2, interest rate factor of 7.2. At t equals 4, we have a discount bond. We had a par bond, now we have a discount bond. We're going to get 95.2627. Our total future value, 122.8719 to the power of 1 over 4, because that was our investment horizon, minus 1. Our realized yield, 5.28 versus 6.2. Had we held it another year, the price of this bond would have been higher because it only would have been 5 years left. If we held it for 6 years, the price would have been higher. Our reinvestment would have been higher. Is there a point in time that we could measure and know up front what our break even would be in terms of time between the benefit gained from the reinvestment of coupon that offsets the loss from a drop in price. What is that time period? And there is a calculation for it. It's called Macaulay duration. It's stated in years, and it tells us for a single instantaneous change in rates of 100 basis points, we would have to hold the bond X number of years to realize our yield to maturity. Describe the relationships among a bond's holding period return, its Macaulay duration, and the investment horizon, and define, calculate, and interpret Macaulay duration, so we will have some calculating to do. So we should be comfortable with the statement that when as a bondholder, we're facing two offsetting types of risk. The first one is reinvestment risk. A buy and hold investor only has reinvestment risk. They have no price risk. An investor who buys a 10-year bond and sells it in 4 has both reinvestment risk and price risk. So reinvestment risk will move in the direction of interest rates. Higher interest rates, higher reinvestment income. Lower interest rates, lower reinvestment income. Price risk works in the opposite direction. If interest rates drop, the price increases. So our reinvestment coupon drops, but our price increases. That's why we say they're offsetting types of risk. If interest rates increase, our price drops, but our reinvestment income increases. For prices, this price up, yield down, price down. When yield is up, this is the standard inverse price-yield relationship we find with bonds. Let's revisit our 4-year, our 4-year investment horizon investor, and let's extend that investment horizon to 8 years now. Remember, at 4 years, the return was 5.2 versus 6.2 because rates had changed. So we're going to increase interest rates 100 basis points. Future value of coupons is 64.0707. Had interest rates not changed, future value of coupons would have been 61.80656. So down here, we see that the increase in interest rates provided coupon reinvestment income of 2.264 per 100 of par greater than we would have had. When we sell it in 8 years, what is the price going to be? Well, that'll be a 2-year bond paying a 6.2% coupon, requiring a 7.2% market return. We'll get 98.19698. If you add the 64 and the 98, you get to 162 as your total future value. Our horizon was 8 years, so it's to the power of 1 over 8. 6.23778 versus 6.2. Very close back down to the 6.2. By going from 4 years to 8 years, we brought our return from 5.2 up to 6.2. Our capital loss was 1.8308. That is 100 minus the 98. Let's lower interest rates by 100 basis points. Here we raised it. Let's lower it. Let's see what happens. Future value of coupons is now 59.6296. So it's down 2.1769 from what it would be had rates not changed. But look at our price. With 2 years left, with a 6.2% coupon and a 5.2% yield required, we end up with a premium bond. It's 1.854 higher. Our horizon yield, take the 59, add it to the 101, you'll get 161. 8 years, we get 6.173, very close to the 6.2. So we're seeing at 8 years, if interest rates changed by 100 basis points, for 4 years, we really missed the mark. We only got 5.2 instead of 6.2. But at 8 years, we're pretty much almost back at 6.2. So that means it's somewhere in around 8 years where these two risks offset each other. There is a formula to determine how long that period of time would be based on the characteristics of each bond. That is called its Macaulay duration. So let's formally introduce Macaulay duration here. We're going to see the word duration a number of times at level 1 to refer to a number of different measures of duration. Macaulay duration is a measure of time. when we move to modified duration and effective duration, those are not measures of time, those are sensitivities. They measure the percentage change in the price of a bond for a change in rates. And then we'll see something called dollar duration. That measures the dollar change. So we have to be careful when we talk about duration. We might think because we're introduced to Macaulay duration, it's a measure of time, we think all duration is a measure of time. That's not true. Even though it uses the same term duration, different measures of duration capture different things. Macaulay captures time, modified captures percentage change, dollar duration captures dollar change. I'll introduce all of those as they come along. When we talk about Macaulay duration, we can use terms longer or shorter because you can have a longer period of time or a shorter period of time. We wouldn't say higher or lower because we wouldn't say higher time and lower time, we'd say longer and shorter. But when we get to modified duration, we would not say longer or shorter because modified duration is a percentage change in the price of a bond. We wouldn't say, but I'm looking for a longer percentage change. You would then say, I'm looking for a higher percentage change. So when we get to any other duration other than Macaulay, we use the terms higher and lower. But when we talk about Macaulay duration, since it's time, higher time makes no sense. Longer and shorter. Just to clear up some language. All right. Macaulay duration, it is the point in time where any reinvestment gain or loss is offset by any capital loss or gain from a one-time, and I'll explain this more, one-time instantaneous parallel shift in the yield curve. A couple of things to point out here. A one-time change. Why a one-time change? If we have a bond, its Macaulay duration will be a function of its observable characteristics, its coupon, the market yield, and the price you pay. And if you change the price, you will change the Macaulay duration. So if you have a one-time instantaneous shift in the yield curve, you will get a new price. That bond will then have a new Macaulay duration. So it's not as if each bond has a Macaulay duration that never changes. Every day that Macaulay duration changes because the time to maturity changes. So Macaulay duration is a dynamic statistic that changes when interest rates change, when the price change, and as time changes. So all we can do is calculate Macaulay duration at a point in time to determine if we bought this bond today, given that that's its Macaulay duration, we know how long we would have to hold it to offset price and reinvestment risk for a one-time instantaneous parallel shift. We say one time because if we do get a shift of 100 basis points, well then we have to calculate a whole new Macaulay duration. Now why is it parallel? Remember, we discount each of the bond's cash flows at a spot rate to come up with a present value. Well, if all those spot rates don't change by the same number of basis points, then we will get different present values for the bond. So that's why we assume a parallel shift in the yield curve, because all we're interested in are levels. Once you get a non-parallel shift in the yield curve, then we have to concern ourselves with the slope of the yield curve. We will get into slope, and the third factor is curvature. Right? You'll see slope and curvature much later on in the curriculum. Right now, we're keeping it nice and simple. We're just dealing with levels, but I want you to be aware of the assumptions we're making. It's a one-time parallel shift. One time, because as soon as prices change, we need to calculate a new Macaulay duration, and parallel because we want to simplify the calculation of the present value without having to worry about spot rates changing by different amounts at each tenor. All right? Great. Let's go over to this first diagram, panel A, interest rates rise. If interest rates rise, what happens? Bang, the price of the bond drops because you have that inverse relationship. And there is our price trajectory. Over time, it's going to work its way to par. But because interest rates rose, the price drop, look what happens to our reinvestment of coupons. It increases. Well, there'll be some point in time over here, which is shorter than the time to maturity, over here, where the distance towards the price trajectory equals the distance upwards towards the reinvestment of coupon. They offset each other. The gain from the reinvestment of coupon totally offsets the loss from the drop in price of the bond. And same if interest rates fall. If interest rates fall, the price of the bond will increase, we'll have a premium, but that premium will amortize to par over time, but we get lower reinvestment on the coupons. There'll be some point in time where they offset each other. Now, you'll see the words negative gap here and positive gap. I'll explain that shortly. So let's go over to the other panel over here. If our investment horizon is longer than the bond's Macaulay duration. So let's just give an example. Let's say the bond's Macaulay duration is 8 years, and we're looking at a 10-year bond, and we're a buy and hold investor, and we say, well, our investment horizon is longer than the Macaulay duration. Our dominant risk is reinvestment risk. We're going to pay attention to the reinvestment of the coupon. That's where our risk lies. And what we don't want to see is falling interest rates. Not because we're concerned about anything about the price. It's not going to help us on the price because we're buy and hold. Falling interest rates means we get lower reinvestment income. If our investment horizon equals our Macaulay duration, that means price risk equals reinvestment risk, we nullify ourselves from interest rate risk. Because if rates rise, we have offsetting risks. If rates fall, we have offsetting risks. And if we have an investment horizon that equals the Macaulay duration, since they offset each other, we nullify that interest rate risk. If our investment horizon is shorter than our Macaulay duration, we got price risk. That is the dominant risk, is price risk, because we won't be holding the bond long enough for the gain on the reinvestment of coupon to offset the price loss that we realize. So our biggest risk is rising interest rates. Yes, it's good for reinvestment, but bad for the price. And since we have our dominant risk being price risk, we don't want to see rising interest rates. Let's introduce the notion of a duration gap. This is the bond's Macaulay duration minus the investment horizon. So again, let's say the Macaulay duration of the bond is 8 and our investment horizon is 10. 8 minus 10 is -2. That is a negative gap. Our risk is lower rates. Now, lower rates because what is our dominant risk? Reinvestment risk. If we are a buy and sell investor and our investment horizon is 4 years, 8 minus 4 is 4, we have a positive gap. Our risk is higher rates. So to calculate Macaulay duration, what we're going to do is calculate the weighted average of the time to receipt of cash flows based on the full price of the bond. And remember, Macaulay duration is quoted as a measure of time. It is the only duration statistic that is quoted as a measure of time. All other duration statistics are quoted either as a percentage change in the price of a bond or a dollar change in the price of a bond. So to do this, well, you're going to need a spreadsheet. That's some calculators have the ability to do this if you enter in all the variables, but typically you'll do it in a spreadsheet. And we're going to assume that same 10-year bond, so time to receipt, there's our 10 periods. If we had a 5-year semi-annual bond, you'd still have 10 payments. So these are basically all of your payments. You'll put all of your cash flows here. We're going to get all of our coupons, and then at maturity we get 106.2. Typically, there's a cell up here. If you're in a spreadsheet, the cell above this row would be the full price of the bond, and then you'd use the IRR function and you'd enter in an array. And the array would have the full price of the bond along with all the cash flows such that you can get the bond's internal rate of return. Because when we're calculating the present value of each of these particular cash flows, we discount it at the bond's internal rate of return. The next column is the present value of all those cash flows, and it should not surprise you that the sum of all those present values should equal the current price of the bond that you're buying. Those two things should be equal. Next column is weight. It's really in the last two columns where all the work gets done. So this is weight. What are we doing? We're taking the weighting of this cash flow versus all the cash flows. This doesn't have to equal 100. If it were a premium bond, it would be higher than 100. If it were a discount bond, it would be lower. But what is the weighting of this cash flow? 5.838 versus 100, 0.0584 or 5.84%. and you'll weight each one, and the weighting should add up to 100%. Then you will multiply the time to receipt times the weight to get this. Remember, it is the weighted average of the time to receipt of the cash flows. This is the weight times the time, right? 2 times 0.0550, 3 times the next one. You add that all up, and there is your Macaulay duration, 7.7429. And Macaulay duration is typically quoted as an annualized statistic in years. So if we look at that, we say, it's 7.74 years. So if we buy this bond today at par and yields shift 100 basis points, we have an instantaneous shift of 100 basis points. We would then have to hold that bond 7.74 years such that the reinvestment of the coupon completely offset the capital loss from the increase in price, or of course rates could decrease as well, and the decrease from the reinvestment offset the increase in the price. Now, let me clear something up, because in previous years this has always been a source of grief here. Let's say that this was a 5-year semi that had a 12.4% coupon. We'll have to say 12.4% coupon because our cash flows are 6.2. Just work with me on this, just because I'm trying to make a point with Macaulay duration here. If this were a 5-year semi, you would still get a Macaulay duration of 7.7429. But that would be 7.7429 semi-annual periods, right? Because this is the number of periods. It just so happened this was an annual bond, and we would need 7.74 periods of time. Since each period of time is a year, it's already a year, but this is 7.724 semi-annual periods. Well, there are 2 semi-annual periods in each year, so you'd have to divide this by 2. There's some thinking that to annualize it, because it's semi-annual, you'd multiply it by 2. No, these would already be quoted in semi-annual periods. Since there are 2 semi-annual periods per year, you divide it by 2 to get years. The Macaulay duration cannot be longer than the maturity of the bond. So there is a simple hint right there. If you multiplied this by 2, you get almost 15. You can't have a 5-year bond with a Macaulay duration of 15, because you can never hold it for 15 years. It's a 5-year bond. The Macaulay duration has to be less. Just in case you run across that issue where you're given a Macaulay duration statistic for a semi-annual bond and it has not been annualized yet, you know that you would divide it by 2. If this were a quarterly bond, our Macaulay duration statistic would be in the number of quarters until the 2 risks offset. We would then divide by 4 to annualize it. Okay, here are 2 screenshots of 2 formulas from the reading. The bottom one is Macaulay duration in a closed form formula. The top one is Macaulay duration taking all the calculations we do in the spreadsheet and putting it all into one equation. And that equation is exactly what the spreadsheet did. I will break down every part of that formula so you'll see that it's really easy to understand, that once you see how it came together, you could pretty much close your eyes and redo it on your own because you'd understand it. The closed form formula, that's a lot to memorize, and I wouldn't bother memorizing that. But we will use it again to explain some of the relationships that bonds have to changes in rates, and look at their Macaulay duration in terms of, well, if we have a premium bond, a discount bond, a zero coupon bond. We'll use this later on. So I'm just making you aware there is a closed form formula for Macaulay duration. Let's look at the top equation, and I've tried to lead you into the complexity here. Payment discounted by 1 plus r to the t. We know that when we're calculating the present value of cash flows, that's really all it is, right? We have our first payment and we discount it at 1 plus r, right? And you have your second payment and you'll discount it at 1 plus r squared, on and on till you have your last payment plus your future value, 1 plus r to the n. So that's all that is, payment over 1 plus r to the t. And we've already seen that if we're between coupon dates, it's just 1 minus the t over t, 2 minus the t over t, 3 minus the t over t, etc. Right? This is between coupon dates. Well, if we take this is the present value of this particular cash flow. So if we take the present value of that particular cash flow over the full price, we should get the weight of that particular cash flow. And that's what's inside the square brackets. That is the weight. Here's the weight of the first cash flow. Let's get a better color on there. Weight of the first cash flow, weight of the second cash flow, all the way to the weight of the last cash flow. And then you weight it by the time. Well, if you have, if this is the first cash flow, you weight it by 1. If it's the second cash flow, you'll weight it by 2. If it's the last cash flow, you weight it by n. But if you're between coupon dates, remember it is 1 minus t over t. And that is what is going on here. This is just the time to the receipt of the coupon. This is the present value of the coupon. When we divide it by the present value, the full price of the bond, we get the weight of the coupon. So it's just time times weight for the first coupon, for the second, for the third, all the way to n. That's all we did in the spreadsheet. That's all that thing is. I wouldn't bother memorizing it. You just have to understand that what we're doing is we're multiplying each coupon's present or each cash flow's present value by its time to maturity, summing all of that up. That's Macaulay duration.